Well, welcome back everybody. In this video, we're going to take a look at our next DMVPN topic, which is going to be a dual hub, single cloud design. Now, basically what that means is we're going to have two different hubs that are going to be able to provide redundancy in the event that one hub potentially fails. So there's a lot of different ways that this can be implemented and things like that. We're going to take a look at some of those details. But what we want to first focus on is the operation of what do we have to do in order to get this to work. So that'll be the first thing that we take a look at. So currently on our configuration, we have the cloud set up currently, and we have iOS 22, iOS 25, CSR 11, and iOS 24 all connected. So we have three spokes in one hub. So what we're going to do is we're going to add CSR 9 to the mix. By doing that, it's going to be just another device on the that's going to attach to the cloud, just like any other spoke would. The difference is we're going to configure it just like we did with iOS 22 as a hub. And then on the spoke side, we're going to specify that we have two NHSs now. We're going to do one to iOS 22, and next hop server to CSR 9. We're going to do that on all three spokes. So when we get that all squared away, we'll have two different hubs. Now, what that's going to allow us to do is take advantage of another variation of how some things can work. So that'll allow us to do some path selection and stuff like that, and we'll take path select. We'll take a look at that in an upcoming video and how we can the different mechanisms to do path selection and stuff like that, just so we can have a different variation of that design and stuff like that. So that's basically what we're going for in this particular use case and stuff like that. So that's basically what we're going to go ahead and do. We're going to get that up and running and operational, and then we're going to verify how it works and go from there. So pretty straightforward stuff for the most part. I'm going to go ahead and clear the screen off, and we're going to go and grab the CLI, and I'm going to go ahead. I'm actually going to close this out because I've had some weird problems with the setup, so I'm just going to go ahead and reset it up here in just a second. And I'm going to grab all of these guys, connect in tabs. I was getting some weirdness issues down here at the bottom. So here we are. So now if I go back to 22 and I do a show DMVPN, currently I have 3 active connections. I should clear DMVPN session peer, and then the peer IP address. The IPv4 address would be this guy. I can do it via MBMA as well. So we should be able to get rid of that here momentarily, but I'm not going to spend a terrible amount of time getting that to work. So what we're going to go do is we know we have from iOS 22's perspective, we know we have the iOS 11, or sorry, CSR 11, iOS 24, and iOS 25. Those are our active connections up and running. So we're going to go up to, we're going to do a quick show run for the crypto, or I'm sorry, show run interface tunnel 1. And we're going to take the majority of this config and we're going to copy and paste it over into the other router. So I'm going to actually take Notepad here. Notepad's going to become our friend at the moment. And we're going to do some quick modifications. I'm going to go ahead and bring this over so it's not so big. And I'm going to take all this configuration right here and we're going to basically populate the config. So I'm also going to go over to CSR 11, show run section crypto, and I'm going to take all of this right here. I'm going to put this in ahead of time. Do this. Let me go ahead and drag this up to the top. And this is how, if I was going to do this in a, if I was consulting and this is how I wanted to do it, this is exactly how I would go about doing it. So I'm going to do this, and then I'm going to specify that it's .9 for CSR9, and that my outside interface is actually going to be, let's do on CSR9. Oh, CSR9 is down. Okay. So I'll have to, I forgot about that. Because I reloaded a bunch of routers and stuff like that. So show IP interface brief. Okay, so I'll have to do some reconfiguration, but not that big of a deal. I'm gonna, before I go into the configuration of the tunnel and the crypto, let's go just do that real quick. So I'm actually going to minimize, let's see. Let me go do this real quick. 10.255.1.23 admin and Eve. Go ahead and bring this guy over. We'll pull up this guy, and on CSR 9 at the bottom here, we're going to go ahead and get him configured, or reconfigured I should say. We're going to go to global config. Host name is going to be CSR 9. Interface gig 1 will be IP address of 10.4.9.9/24. We're going to no shut that interface, and then interface gig 2 will be the same thing. Gig 2, in this case here would be 3.9.9. No shut. Bring that guy up. That'll take care of that. And then we'll go to interface gig 3, IP address of 29.0.0.9/24, and no shut that interface as well. And then we're going to do a router EIGRP1 network of 10.3.9.0 We'll do the 4.9, and then we'll go and we'll do a network of 10.1.1.0 We'll get that guy squared away, and then IP route to 0.0.0.0 to 29.0.0.2, and do write. So we want to make sure that we have saved that configuration. So it gets us up and running rather quickly in our setup here. So what I can do now that I have this router set up and ready to go, is I can actually bring back in our PowerPoint and secure CRT and bring this back over. So now I know the gig 3 is our main interface. We're not going to be running this in a VRF, and that's pretty much what I need to have there. So I'm just going to basically take all this config right here, and I'm going to copy and paste it into CSR9. So assuming I've done everything correctly, we should have the tunnel come online, and then we won't actually have any EIGRP adjacencies form yet. Okay, what we'll have to do is we'll have to actually minimize this, and we're going to go to 24 and do a show run interface tunnel 1. I'm going to take this config right here, interface tunnel 1, IP NHRP next hop server is going to be 10.1.1.9 with an NBMA address of 29.0.0.9 and multicast. I'm going to take this config and do show history. No. So now we have an EIGRP adjacency with that guy. What I am going to do is I'm going to take this line of config right here. I'm going to go to 25, interface tunnel 1, and I'm going to copy and paste that config in right there. CSR 11, same thing. Config T, interface tunnel 1, and then copy and paste that config in there. So by doing that, I will form an EIGRP adjacency with both of the hubs. So pretty straightforward configuration from that perspective. CSR 9 now has 3 EIGRP adjacencies, 1 to each spoke. Show DMVPN. There we go. We're going to do a show IP EIGRP neighbors. Those neighbors are up and running. And if we do show crypto session, we have a bunch of crypto up and running. 1 to every connection, show crypto ISA SA. I have connections to each one of those nodes. So at this point in time, we have the configuration where we want it operationally and working. So that is dual hub. So if we go to 24, for example, and I look at the show DMVPN, I have the connections up and running. And if I do show IP EIGRP neighbor, I'm going to have 2 tunnels, 1 to each hub. That's working the way that it needs to. And that's operational. So now we're about 10 minutes in. And one of the things that you run into now is you've got 2 paths, 2 equal cost paths to everywhere in the network. Okay, so let's go take a look at this. If we look at this from the perspective of iOS 24, show IP route EIGRP, I'm going to have 2 paths to everything. So let's go ahead and bring this up a little bit. I'm going to have 2 ways to get to Nexus 20. I'm going to have 2 paths to get to the iOS 34 up at the top there, so on and so forth. As you can see, it gets a little messy, right? So there's a couple of things we need to do in order to prevent any type of asymmetric routing and stuff like that. So let's do from 33. Let's do a show IP route. We're only going to have one way of getting to everything from here. But if we do a trace route to 172.16.101.34, sourcing from loopback 0 numerically, from here it's not that big of a deal, right? So we get to 34. Let's see if 34 has a problem. Show IP route. This is not doing anything other than layer 2 connectivity. So if I was to ping 33.33.33.33, I should be able to reach it and do a trace route to the same address. Numerically, I should be able to get there all day long. 33 should be able to do the exact same thing. So we eventually end up getting there. It goes all the way. It seems a little weird with some of the routing issues you get, but this is what I'm talking about. You get into weird problems where you get to iOS 22, but you could take both paths. Now, if we go to 24, it's a little bit different. If we do a trace route to 172.16.101.34 and do it numerically, we multipath, right? And that's not good. So we don't want to be equal cost multipathing, especially over IPsec tunnels. It's not a good mix, especially with the SPI values and traffic coming in on one interface and coming in back on another. It's just not smart to do that. So what we're going to go do is we're going to go and make some modifications. So we are going to prefer iOS 22 as the primary hub. What we're going to do on CSR9 is we're going to go on, if we look at switch 4, for example, and we look at the show IP route, we're going to see multiple ways to get to a lot of different things. So we see them over going via iOS 22 and also CSR9. So what I'm going to go do, and this is the way that I would do it in production, is I'm going to make a change on the tunnel interface on CSR9. I'm going to bump up the delay. Since we're using EIGRP, that makes a lot of sense to do that. So from a route propagation perspective, we're going to less prefer CSR9, but we're going to prefer iOS 22. But it's going to be bidirectional to a degree, and we're going to talk about how that comes into play. So on CSR9, I'm going to go to global config, type in interface, tunnel 1. I'm going to type in the delay is going to be 10,000, which if we do 10,000, that's actually going to be 100,000 because it's in tens of microseconds. So I'm going to do that. And once I've done that, then if we go back to switch 4 and we hit the up arrow and we hit the show IP route, you're going to see that we've had a routing change and we're going to prefer iOS 22. If we go down to 24 and we do that show IP route EIGRP, we are also going to prefer iOS 22 for most things. If I do the trace route again, I'm going to prefer both paths to get to something behind the tunnel, because I still have, in this particular case, anything behind the hub is still going to be an equal cost path, right? We can see that that's not changing, and it won't. So in this particular case, we need to do some stuff. We have a couple different choices. We can either go on the hub side on CSR9, and we can do a summary route on the tunnel out towards all the routers. So if we go over to iOS 25 and we do a show IP route EIGRP, we are also going to see the 172.16.101 network is going to be available through both hubs. So basically what we want to do is we want to go on the CSR9 side if we want to do any type of longest match routing. So the logic is that we will we can turn off delay if we want to, but we're going to leave it on because it's going to it affects a greater number of routes with a single change. But we want to affect how the spokes see the communication. Because if we go down to switch 4, for example, and we do a show IP route, you don't see any duplicate routes, right? The only duplicate routes you see in the routing table are anything to get to either CSR9 or iOS 22. But those are the connected transit links, and I'm okay with that. So because that's what switch 3 is advertising to us. So we're not concerned about that. We're concerned about the spoke to hub communication. So on CSR9, I can type in the IP summary address for EIGRP 1, and I can specify a particular prefix length. So I know it's a 172.16 address, so I can type in 172.16.0.0/16, for example. I can do that, and then I'm going to wait for the tunnels to resynchronize, and then once they resynchronize and they're good to go, I go back down to iOS 24, I hit the enter key, and one thing we're going to see is that we're going to have 2 routes being propagated from the hub now. We're going to have one that's going via CSR9 right here, which is a shorter match, and then we have the longer match via 22. So if we do that trace route again, because remember before the trace route still showed us ECMP forwarded, right? If we do that trace route again, we're going to prefer iOS 22. And that works out really, really well. And it actually makes a lot of sense to do that. That affects still a large number of spokes. If we go over to 25, we're going to have the exact same output, right? That we see that to get to 101, we're going to go towards iOS 22. That makes a lot of sense to do that. But what happens if you don't want to do that? What happens if you have a reason to load balance? I can't think of a legit use case to where you'd want to do that, but you might. So we're actually going to yank that off. We're going to type in no summary address. One other option that we have available to us is on the spoke side, which is less scalable, obviously, because we have to do it per spoke. If we go back to 24, we do show IP route EIGRP. We see that it's changed back. We do a trace route. We load balance again. Now what I can do is I can go global config, and I can go underneath the tunnel, or I'm sorry, underneath EIGRP, router EIGRP 1. I can type in the distance for EIGRP is going to be 91. I'm sorry, distance is going to be 91 for anything coming from 10.1.1.9 and 0.0.0.0. So what I'm doing is I'm basically saying any routes that come from CSR9 I'm going to have as a higher administrative distance. I'm going to do that. That's going to cause traffic to bounce. So once this goes into play, it's going to take a couple seconds for it to actually trigger. But once it does, and there it goes, once everybody's happy with the outputs and stuff like that, then we'll be squared away. Is now we have to look at the we do a show IP route EIGRP, we're going to see that only traffic from iOS 22 is being learned. So there is no CSR9 routes being learned, at least nothing in the routing table. And that's okay. I'm okay with that. Now, if I was to go into how do you validate that that's actually working minus doing a show run EIGRP? You can do a show IP protocols and hit this and go all the way down to the bottom. And I believe we can specify, yeah, let's just go all the way to the bottom. Right here, you'll see that for this particular prefix, we are, anything that's coming from CSR9, we're going to go ahead and give it a distance of 91. You can see it here as well. So that's basically going to restrict any routes from being learned from there. If we do a show IP EIGRP topology for just, I don't know if I can specify a neighbor, and I cannot. But as you can see, we're learning multiple routes from CSR9. We're still learning routes, but because we've given it a higher value, we're going to be choosing that particular path. So if I was to go in here, and you can see right here, when you look at traffic from 172.16.101/0/24, the feasible distance is the same from both peers, so they would be equal cost routes. But if we have it set up like this, to where we look at, I should be able to look at topology and this particular prefix right here, we can see we're learning it from both peers. But by modifying the EIGRP distance, I'm only going to install one of those neighbors as the next hop. And this is going to be how you can filter the routes out and eliminate any type of loop or asymmetric routing that might be brought into play that could potentially cause you harm in the network and stuff like that. So a little bit of path selection that's definitely worth knowing and worth having in play if you're interested in going down that path. So that's pretty much it for this particular video. I wanted to demonstrate those specific characteristics and capabilities. And until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video.